Okay, guys, so I don't want to make you wait any longer. We will start right now. And you all have the screen. You should be able to see the screen and you should be able to see the slides. That's the point number one. Point number two is when you have questions, which are very welcome, then you won't be able to say that, but you will be able to type them. So I hope you can all find that place where you can type the questions, and our team, they will give me those questions, so I will be answering them. Not maybe right away, but after a short time I will. So if you go, you all guys are ready, then we can start. Okay. So that is presented by 1 second, by the Starweaver group. And the Starweaver group will give you a big introduction at the end where we will talk about the additional perks and prizes that you might get. There is a lot of training and teaching content on the Starweaver site, and also that will be given to you as a result of attending this webinar. So with that, we can start, and I'll show you how you can find the bad guys or catch the bad guys in a somewhat unusual but highly technological way, how that will actually work for very different applications, and how we have recently done this project so that we know that it does work. There will be a demo there. At the demo, I will show you exactly how you would code it, not all of the code, but at least the beginning of the code, so that you can see that, yes, here it is, I know how that would work in general. And that is the whole purpose. The whole purpose is introduce a new way to solve your problems. So let us start. The two technology components we'll be using are Spark and Elasticsearch, but that's not the biggest point. The biggest point is that you can combine two new technologies in the right way, and what that will give you. Here's what we want to show you. I want to show you a typical big data application, but then I'll show you how to enhance that with search. Then the next question will be, okay, I got my search, how can I use the data? So I'll show you how would you use the data with Spark. And that leads up to the machine learning component, which we will show later on. So the first point is this. Elasticsearch, which you probably heard about, is a search engine. And that is how most people would treat it. They will think that it is a search engine. The story behind it is a bit longer. Here's that story. Originally, Doug Hutton, that guy whom you may know because he also invented Hadoop. So this guy created an open source project called Lucene, and it was a search engine, but not a... Thanks, guys. Okay. But that was not a UI-based engine. It's not Google. It's a programming tool. So here it is at the top, a programming tool called Lucene. That became very popular because it was replacing very, very expensive commercial search engines such as Inktomi that would cost you 10,000, and that was 20 years ago at this time. But then people realized that they need something better and nicer. So the first better and nicer attempt was Solar by this guy on the right, by Yonik Seeley. And it is a great open source project, but then there appeared a new company, Elasticsearch, right here at the bottom, who wanted to do it right. One of the things that they do is scalability. If you're using more than one computer, then you would like to have what is called a cluster. And Elasticsearch solves this problem in a very nice way because those servers look for each other, find each other, and join into a cluster. That's nice. That's, I would say, better than Solar, which uses a way to configure. Both of them, in the end, use Zookeeper. So it's not surprising that the result will be technically sound, but it's the convenience of administration. When you look at Elasticsearch a little bit closer, you will see that it does a couple things. First of all, it divides your search index into what they call shards. Here's one, shard 1, shard 2, shard 3. These all are there because eventually your index will grow. If you index at 1,000,000 documents, maybe it's one computer, but 100 million, that is already a cluster, and it may not even be able to reside in one particular piece, and that piece is called the shard. So they will break the cluster into a few multiple uh, shards and place these shards potentially in different nodes. In addition, they want to be fault tolerant so that when a server fails, which is always a when, not if, when that server fails, then there is always a replica. For example, for shard 1, there is a replica 1 here on the right, and that replica will take care of all the data that was there. So that is how most clusters are organized. They all have to be fault tolerant, they have to replicate the data, and that is how Elasticsearch is organized. That I think is nothing new. What is new is that it is very scalable, very easy to scale, and in addition to giving you a ready-to-work search solution, they also give you a few more components. They give you Kibana. I'll show you the Kibana. It's a nice UI on top of your search. And they give you a few tools to load the data. So there's bits and logstash. Bits is a very simple, small component, and logstash is bigger. And it allows you to bring in hundreds of different sources. Now, in my case, the one I'm talking about, it's a big bank that wants to find fraudsters. So they won't have all that many different data sources. It will all be from their own individual database. And there are many different ways how to do it from the database, but I'll show you the best one. So this is what you start with. Let us say you're looking at logs. And when you look at logs, that's the kind of garbage that you see. At least it looks like garbage from afar. It really is not garbage. It's the standard Apache log format, and it would be nice to somehow present it in a better way. So that's what you would really like. You wouldn't want this black stuff that's hard to read, but instead you would like to be able to see it, let's say, as a diagram, maybe as a chart, traffic versus bytes, how much traffic is going through your site. You might want to see the response codes. Are people getting the 200? That's a good response code, and most of them are in that example. But some may be getting the file not there. This is 404, the file not there. And that may be because your site is broken in some places, or some may be actually getting some bad code, which is indicative of hacking. So you'd like to have this diagram. These diagrams are called visualizations, and you build them with the UI called Kibana that Elasticsearch as a company wrote and supports. In addition, you can take multiple such visualizations and bring them into one dashboard. What I'm showing you here is exactly this. That is a few, in this case, 5 different visualizations that I brought together in one dashboard. So let's stop for a second and think, what are we doing? We want to have a data source. Every application, let's think of old style application, database and a server. So every application would have a data source. Let's call it data store. And what I've shown you first here is that your Elasticsearch can act as a data store, something that maybe you never thought about. In our case, we had about 30 billion records that we needed to store, and I'll show you how you verify that you have enough capacity to do this. But if you use this Elasticsearch as a data store, as opposed to maybe Oracle or maybe even Hadoop, you'll get a couple advantages. The advantage number 1 is that you can see all of your data. The advantage number 2 is that you get text search capability, which is very special. No other data source will give you this search capability. So I'll show you how that works, but for now, let's continue. The Elasticsearch as a company needs to make money. So they have a component called XPack. XPack is something that works together with their standard distribution. So you start by getting the standard distribution, installing, using it. But if you also, in addition, install XPack right into your distribution, you don't need to redo anything, repackage the data. Nothing. You just install it. You get additional components. You get reports. You get more of monitoring. So that's what you can get from Elasticsearch if you want. Once you have your Kibana, and that is that component that I was showing you, you can now do searches. In this bar here, where it says use Lucene query index, that's where you can do the searches, and you can see I'm searching for the word Firefox, and I'm finding that the word Firefox everywhere. So that is a powerful search syntax. Most people have the idea of that because they all use Google, and Google gives you pretty much the same syntax as Lucene, just a few changes. It can be very specific. The query can be very long. You can say include these words, exclude these words, put these words close together, and so on. So you get a full search. And now, if we're going back to our original goal, we want to write an application that will store all the data, process the data somehow, and then allow us to hunt after the bad guys. Then you realize that you could do it like in a database looking for unusual transactions, or you could also add text search, and that will be very helpful. This, what I'm showing you, is another chart that you can have if you want. It's a response code by number. So on the right, I show you what response code I'm getting, and on the left, I show you the actual chart. Very good. So dashboards are visualizations. You just simply select which visualizations you need to add because you have created them early, and that would be your dashboard. And to summarize, before we do the demo, to summarize, we have now a data store. Now you can build on top of that. I'll show you one thing that I have built on top of that, and then we'll go back and to see how much progress did we make. What I'm showing you here is an open source application for lawyers. Lawyers are such creatures that like to sue people for gain and for fun, and they form lawsuits and file those lawsuits in a court. After that, the judge says, hey guys, there has been a lawsuit filed against you. You should realize you've been sued, and we'll send you more information. And what they send you is a request for all of your data that has anything to do with the lawsuit. And the American laws, that's a valid request. Now you have to produce, you have to give them all of the documents. So that is exactly what this application is doing. If you're interested in this, you just go to Freed. That's where this software is available. Sorry, not UI, just Freed. So that resides here. You can download, you can look at it. But here's the live version. The live version is right here. And what it allows you to do is you can search through your cases. So maybe there are a few cases like here, and you want to search through the cases and find any incriminating evidence. Like, for example, let's say if we look for some of the standards cases, like I lied. Will there be such a thing that I lied? Yeah, there will be such a thing as I lied, and probably a few times. The problem is it's looking for either the word I or the word lied. So that's probably too much. So let's try to look for the word lied. And that's much less, just one. So we can take that word out. And then we see that, yes, somebody lied somewhere. We should even see where exactly he lied. Let's see. There you are. Lied about misstatement, you see? So that shows us that on top of our store, and if that store is Elasticsearch, then we have all of the other tools like Kibana. On top of that, we can build useful applications. We can look for specific words. This is much better than what you get with the databases and even with NoSQL databases. So let's go back to our slides and realize one more thing. That's a diagram of how that particular application is constructed. It is based on Hadoop because you need some very scalable processing system. We will be back to that very important question of we need a scalable processing system. But for now, we realize that yes, we have this data store, and on top of that data store, we can build our applications. So our next step will be, I'll show you that a search engine is also a NoSQL database, which not everybody realizes, and that will give you some more ideas on what you can do with that. Since we're having a natural little break here, if you want to type any questions about the first section, which was Elasticsearch as a data store, then you're welcome. But let's continue. So we said Elasticsearch is a data store, but it is also NoSQL. How is that? That is because it uses essentially the same format to store the data. If I draw up a comparison, like here on the top, when you store a document in a search engine, you also store essentially a record. That will be right here, document. The document in the search parlance is the same as the row in SQL. The document has a key, a primary key, and the table very often has a primary key. The document that is being stored is essentially a record, so it has different fields. And in the SQL world, it has columns. So far, we do have a parallel between a search engine and the SQL. But if we go a bit down, we can see that there is more parallel with the NoSQL. That is because in a NoSQL, there is this one row key, which is a must. It's not the same as an index. And it also has fields, which is similar to NoSQL because these fields are, of course, present in a NoSQL. You can do any kind of a field, unlike SQL, where you have to have it structured. In the NoSQL world, you can put any field name because anyway it will be stored as a column name and column value. Well, pretty much the same story happens here on the left with the search engine. You put a field, which you decide what it is. It may be all of the text in the document, but it doesn't have to. It could be the author of the document. That's also a field. The date of last access is also a field, and so on. So you can have these fields, and in the latest version of all of the search engines, these are quickly accessible individually. It used to be that you had to take the whole record of the document, erase it, create a new one, write it. That's a slow process. But today you can update specific individual fields. Once you realize this, then the table at the bottom makes a lot of sense because that's a complete parallel between search and NoSQL. If so, if our search essentially is a NoSQL engine, then what we can do now is we can think of how do we model our data. We know how we model our SQL data. For that, we go to school that's called Normalization School. We also know that once you start doing things in the NoSQL world, they tell you forget everything you learned about normalization because we completely changed that. There is no normalization, just the other way around. We denormalize the data, we store the data 2, 3, 4 times, and we think of what to do. All right, and that's the result. For example, if you want to store, let us say, let's imagine we're storing transactions, and each transaction is a credit card transaction. And then maybe we're storing some special data about these transactions. So in order to create a data model for that, I would immediately go to the classical examples. For example, let's take, that's an example from what we teach. Let's say I want to create a user table and a video table. So how would I have a one-to-many relationship represented in the NoSQL? This shows that the way to do this is to put all of those menus into the same row. So I'll have the user ID and all of the user videos, which might be in hundreds, thousands, and maybe even millions, will be in the same row. That's not a problem for NoSQL because it can have any fields that you want. So that is how you would represent a one-to-many relationship in the NoSQL. In the same way, you can then answer any other similar question. You'll go to best practices in the NoSQL, Actually, when we teach it, it's a lot of fun because we divide people into groups and they need to design the best possible tables representing these relationships. And then after a while, they say, "Oh, that's what it is. That's not all that hard. Now I understand. That is what you get." So you create a table, and then you can store not just individual documents, but now you store a certain schema. You can find all of the, let's say, notifications that belong to that particular transaction and the other way around. So good, you stored it. You can get one document at a time. It is searchable. You can do the text search. You can look for bad guys. For example, recently I watched a video about one pretty bad guy. He was a carder. He stole like about $30 million worth of money and did it with the card uh, selling business. So he was very significant. It's interesting that he did a lot of things just by himself. Once they found, got him and put him into prison, was a Russian guy. So that made Russia very upset, by the way. So that all pretty much stopped. The reason I'm saying this is that this guy wasn't careful enough with operational security and he used his username. So a search, one search would actually would have found him, and that is actually how they found him in the end. So search is a very powerful tool in addition to your analytics. But still, then you may want to run analytics. So again, you will say, okay, I know how to do this. My search engine is just a NoSQL engine. And with NoSQL engines, I know how to do this. For example, here's an example on Cassandra. On the left here, I have that part of the engine that's responsible for real-time transactions. On the right here, I have that part of the engine that's only doing analytics. That way, if I have an analytics query, it goes to the right part of the cluster. If I have a transaction, it goes to the left part of the cluster. And the connection between them makes sure that it is all balanced, that it is all replicated. So you can do the same thing with the search engine. And what I'm showing here is the cross-pollination. The ideas that you get from NoSQL, you can then move them and use them in the design in the search engine. So good. Now I got a scalable storage. It's a cluster. It may be a few dozen machines. And then my question is, I'm used to writing my software for a single server, and that won't work. Because if my data is on 100 machines, then probably my single server won't be able to do this. Well, think of what is the best big data processing engine. We can do such search for fun. I'm quite sure that one of the top that will come up will be Spark. So what is Spark? Spark is a kind of a new Hadoop. You can think of it this way. It's in-memory big data processing engine of Hadoop. You can compare it to some old cartoon ideas about PC and the Mac. But the end result is that it takes all of your data here on the left, and it brings it into memory. Here we show those memory blocks being 64 megabytes. They're called partitions. And then it does this processing in the memory, and that is much faster. So the amazing thing, and that's the bigger point here, is that yes, I have my storage, I have my search engine, but how do I process it? Well, you can combine this with Spark, and Spark will give you the capability for very fast processing. So let's continue. I prepared two labs. Now, a disclaimer, labs never work. That's my rule. Whenever you're trying to show something, that probably something will break. Nevertheless, I'll try to do this. And if it doesn't work, you will have the fun of seeing me fighting with that. Let's do this now. So first of all, let's open that lab, which I prepared for you. There you go. It doesn't work right out of the box. But for that, I know what I need to do. I'm just hitting in and I'm starting that server. Now that lab should work, and it does. I should be able to even get out of here, and it should still work. Yes, it does. Very good. So in this lab, I want to show you how you would install the basics. I actually did it already, but I want to show you how easy it is. So the first thing is we unzip Spark, and then we call it Spark so that we can start our Spark in an easy, simple way. But the next one is different. You need to make Spark and Elasticsearch work together. For that, you need to get a library that will be living in between them, and that's called Elastic Spark right here. So here you would get it from, in my case, I prepared it on S3, but you would get it from Elasticsearch, and then you would start the Spark shell, but this time you're starting your Spark, and you are also giving it a jar where you want it to run. So here's what I'm doing. That's the command that I need to do in order that I can talk from Spark to Elastic. Let's do this. Okay, I'll make it bigger so that you can see. I'm logging in again, just like I already did. And then I'm starting Spark in this special way, as you can see, where I'm saying, and use this additional jar. So let's see if it works. Okay, we have it. So we can do things like help, just for fun. But that's not important. What is important is that I want to take my data and write it to Elasticsearch from Spark. Here's what I'm going to do. I'm going to form my data. So first the necessary inputs, and then I need to tell one interesting thing to Spark. Here, I have to tell the search engine that if I'm putting the data into a table that never existed, more correctly, into an index that never existed, then it should create this index on the fly. That's easier that way. Then I can create other necessary inputs from Elasticsearch, as you can see, and create some data. This data I will create right here in memory, like this. So I created numbers. This is a simple collection, but it has all that the search engine needs. It has a key and the value, a key and the value. I should be able to search that. That's the numbers. There are also airports, just to show that I can have a different data structure, and that has string to string. So it has the key and it also has a value. Good, so I created some data just to demonstrate that yes, indeed, I can write straight into a search engine from Spark. And here's the command to do it. That's the command to do it. That will write into a Elasticsearch. How do you know it writes to Elasticsearch like this? So that's one of the cutting edges today, because even to find that documentation wasn't easy, and some of that I had to dig up and find it in the code. But then once you are there, then you realize, yes, that's how it works. And actually from the code, I was able to then search and find the documentation on the web as well. So what did we achieve? We showed that you can match one cluster against another. What we've done so far was this. We can use Elasticsearch for storage, and that's great. We can also try to match the capacity of the storage with the capacity of the processing, and that we do with Spark. Now I can create a huge cluster of storage, let's say 100 machines, and another huge cluster of processing, and that's Spark. And in order to test that and verify that it can store my billions of records, I will run that as services on Amazon. That right now I'm not showing because it will take more than just a few minutes to start. But you can experiment in any cloud actually this way. If I want to see that, yes, indeed, I got this search engine running, then I can try to just list data in my search engine. That's how I usually do it. I'll get out of Spark, list the data in the search engine, And you see that same data, you maybe noticed that's the airport that I have just put. So that short demo was to show that yes, you can indeed match the processing of the cluster on one end with the Spark on the other end. The other demo would show how you do it in the modern version of Spark and how you would be reading lots of data from the hard drive. Okay, so far we've done this. We showed you the processing and the storage, and now we have a match. So you can either search for the bad guys by issuing individual queries, which you will start from. If you're in this area, you probably know how to do it with the database. So you'll start from the database. You will translate these queries from what you knew about the search engines, and you'll put these queries from SQL into the search engine. Your next call will be machine learning. That's because there is only so much investigative work that you can do, because that's each individual person doing his investigative work. In the end, you'd like to do something better. You'd like machine learning. You'd like, for example, to look for anomalies. You could say, well, I don't know what's wrong. I understand that people are very smart about finding things, but I also heard that there are computers, machine learning, that are also that kind of thing, that are also quite smart about doing this. So here's what you could do. You could use a method called, for example, anomaly detection. Anomaly detection is a general idea which will say this. Let's say this blue is normal. I know that this red is not normal. How can I separate them? Is there any way for me to write down a formula that will later on tell me that new point, is it normal or is it fraudulent? Well, yes, there is such a formula. It's called SVM, support vector machines, and it's just one of the possibilities, but that one is very popular in the fraud fighting world. And uh, uh, in this case, it's just 2D, two-dimensional, but in the normal way, your transactions are characterized by quite a few parameters, like how many dollars, from where to where, how many other transactions of that sort I already saw. So all of that is going into this anomaly detection, and you can then run your machine learning algorithm. Spark includes that. Spark includes your machine learning, and therefore you can run your library within the same environment. Now, what we have achieved is we have the storage engine, that's Elasticsearch as an example. We have the processing engine, and we even have a machine learning library to go with that. That explains exactly how the SVM works. In particular, it's trying to find the plane that will separate your variables the best. It's the best possible separator between the two. And that will happen if your points that are closest to the other guys is still far enough from them. So that is a picture that illustrates how this SVM works. Okay, that was the final goal. So we went through three stages. We said, in order to store all of our data, let's say 40 billion transactions, we can use Elasticsearch. What we'll get then will be two things. First of all, Elasticsearch is a search engine, and so I can search text, and that is very helpful, searching for fraudulent stuff and bad guys. Secondly, I can also use all of the NoSQL knowledge that I have, because a modern search engine is essentially a NoSQL database. I can then model my data so that I can include dependencies between, let's say, guys and other guys, so that they can build a network of bad guys, or network of all guys, and maybe find the bad ones. The next step is I realize, okay, I got this storage, wonderful storage, but how do I do processing? And that was Spark. And finally, since we're in Spark anyway, and since machine learning just begs to be let into the picture, I showed you how you can then use machine learning to find these bad guys with that storage that you already have, and in that environment, which is Spark, that you already have. That pretty much is it. So right now we have a few minutes to finish this up, and also to answer any questions that you might have. So we'll wait a little for the questions. Okay, very good. So you will get an update, an email update. And in that update, you will get the additional goodies that I promised, the coupons, the additional courses that you can take for free. And also it will contain the what's next, what's next steps and all the needed information about Starweaver. And so if we don't have any questions, then thank you very much, guys. It was a pleasure presenting this to you. You might want to ask questions later on, maybe in the email. So for that, you'll just get in touch with Paul Siegel of Starweaver. Thank you.
Thank you.